everybody. In this video, I want to talk more about sets, but focus specifically on those definitions in math that we tend to see a lot. So things like the real numbers, natural numbers, irrational numbers, and so on. So let's talk about these specific sets in mathematics. So I will say that there is a whole other branch of math that deals with numbers that are not real. They're called imaginary numbers, but more formally, they're called complex numbers. And complex numbers include both real and imaginary numbers. So just want to make a note that there is more out there, and you're going to get there, particularly in the 162 class. So there's more than just these sets that we talk about in math. Real numbers are really just one branch of mathematics, and there are imaginary numbers too that we can talk about. So I'm going to focus on the real numbers here and talk about their subsets as well. So the first, actually, let's start at the top. So let's talk about the real numbers first. And it's just easiest to do, I think, with examples. So your real numbers are basically everything that you probably know. So everything that you've probably learned up until this point, unless you've learned imaginary numbers, of course, those are not included here, but the numbers that you learn as a child. So they're your counting numbers, your integers, your fractions, your decimals, things like that. So your real numbers are really all of those things. So examples, things like, 0, 5, -10, you have fractions there, you have decimals, you can have repeating decimals, etc. So really anything here. You can even have things like roots, square root of 2. You can have numbers like pi, which we know is about 3.14. You can use a calculator to figure out that one, and so on. So your real numbers incorporate all of these. And then under your real numbers, we have different subsets, so sort of subgroups of real numbers. So under the real numbers, it breaks off into two sections first. So you have your irrational numbers, and you have your rational numbers. Okay. So your irrational numbers, these are basically decimals that do not repeat, so there's no pattern, and they don't end. So for example, I'm just gonna make this up, something like 1.256003214, etc. So there's no pattern there, it's not repeating, it's just gonna continue on forever. It also includes things like your roots that do not simplify perfectly, like root 2, right? 2 is not a perfect square. So that would be an example here, or square root of 5, for instance. Basically, if you put that into your calculator, you just get a long string of, it looks like random numbers. So those are included here. And then also things like pi, for instance, and those are E, numbers that we give special symbols to that represent these very, again, kind of complex, long numbers that don't have a pattern. So those are your irrational numbers. Your rational numbers are everything else. So basically, this is any number that can be written as a ratio. That's the definition, ratio, which is a fraction. And this ends up including any whole numbers, any integers, obviously fractions, and it also includes decimals that end or repeat. So for instance, something like 0.3 that repeats is actually the fraction 1/3. 0.25 is actually the fraction 1/4, etc. So your nice decimals actually could be written as ratios. So that's where the definition comes from. It also includes things like roots that would simplify. So for instance, if you had the square root of 25 equals 5, that is another example, right? So anything that kind of comes out nice, those are your rational numbers. And under those rational numbers, we break them up into groups again. So your next set is your integers. And these are your whole numbers, but they do include negatives. Notice I'm using that set notation here with those squiggly lines. And then under your integers, the next set is your whole numbers. So these start at 0 and go up. They do not include your negatives. And then under that, you have what are called your natural, or sometimes called your counting numbers. And that starts at 1. So that's what you learn when you're a baby. That's why they're called your natural numbers. Now, all of these do have fancy symbols too that you may notice. So the real numbers, you will sometimes see written with this symbol here. In the computer, it looks a little bit nicer, but it kind of looks like almost like a bold R, but with lines around it in a way. So you'll see it in your text. Let's see, rational numbers, we usually write with a Q. So by hand, I tend to write it like this. But again, it looks not quite bold, but like it's double lined. Integers, you actually will see the notation with a Z. So like a double Z. Let's see, your whole numbers is a W. That one's straightforward. And again, I'm kind of just going to try to double line that here. Natural numbers, you have that double N outlined. Your book kind of writes it this way with the double going that way, but you have some sort of double line there. And then your irrational numbers, we do use that kind of double I. So it almost looks like this. So if you see any of those notations, they are representing these specific sets of numbers. And what's happening here is we're sort of scaffolding down, and all of these pieces underneath are subsets. So as a side note, a subset is a set that is contained in another set. So for instance, the natural numbers is a subset of the whole numbers because it's contained in the whole numbers. They're all included. And then the whole numbers are a subset of the integers, right? Because all the whole numbers are included in the integers. The natural numbers are also a subset of the integers. So these are all subsets really of each other. And all of these are subsets of the real numbers. Let's do an example here with some of these sets. And the interesting thing I do want to point out, and this will help us in our example, is again, because we have this idea of subsets here, some numbers can be more than one thing, right? So the number 5 is natural. It's a whole number as well. It's also an integer. It's also a rational number because I could write it as 5/1. That's a ratio. And it's also a real number. So some numbers are going to be in multiple sets like this. All right, so let's do an example. We're going to list the numbers in the set that are, so I want to do our natural numbers, whole numbers, integer, rational, irrational, and real. And this is the set that we're going to use. So let's use the set -8 4/5, or -4/5, 0, 0.7 repeated, square root of 7, pi, 8.1, and I'm running out of room. How about the square root of 100? Now, if you need help, you can take out your notes from the page before and kind of go through all your different definitions again. So what I'm going to do is go through and just see, okay, which numbers fit into each category. And some of these numbers can be in more than one category. So for our natural numbers, remember your natural numbers start at 1 but they're just your counting numbers. So do I have any of these here? Well, my negative numbers are not natural. 0 is not natural either. I do actually have one. The square root of 100 is the same thing as 10. So I do have a natural number here. The square root of 100, which is 10, is our natural number. Now your whole numbers, remember, are the same thing, but they're going to start at 0. So for our whole numbers, I do have 0 there. And again, I also have the square root of 100 because it's 10. Our integers are the same thing, but they include our negatives. So -8. Now this is a fraction, so it's not a part of the integer group. 0 is an integer. Let's see, and then just the square root of 100. Let's fix that. Okay. Now our rational numbers, again, you want to be a little bit more careful. So your rational numbers are any number that can be written as a ratio or fraction. So it includes whole numbers automatically because, again, something like 5 is 5/1. That can be written as a fraction. It includes fractions, obviously, and it also includes decimals that end in, or repeat, that have a pattern. So I have -8. Now here is a rational number, right? It's a fraction. 0. Here's a decimal that repeats, so it is a fraction, or it can be a fraction, it's rational. Square root of 7, if I plug it into my calculator, I'm going to see a whole mess. There's no perfect pattern there, so that is not rational. Pi is not rational. 8.1 is rational, though, because it has a decimal that ends. So again, any decimal that ends or repeats is rational, and the square root of 100. And if you need to go back, you can fill in that here. So any number that can be written as a fraction, whole numbers, integers, I should say natural numbers too, I guess. Fractions, decimals that end or repeat, and of course, square roots that are actually integers in disguise. Now your irrational numbers are going to be different than this. So these are your messy ones. So we have our square root of 7, and we have our pi. Another thing to note with rational or irrational is that you cannot be both rational and irrational. This is a nice little tip. So a number cannot be in both these groups. So if you have the same number in both groups, something is wrong. All our real numbers are either rational or irrational. You have to be one or the other. If you look at your chart on the page before, you can see all real numbers break into either irrational or rational, but these are different things. And then finally, for our purposes, all these numbers are real. So as long as it's not imaginary, which we haven't learned yet, they're all real. And the thing is too, for imaginary numbers, just as a side note, if you see something that is imaginary or even complex, we use that term. They're not quite the same, but they're very similar. You're going to see an I in it. So for example, it would have something like 8i, and we use that I there to represent those imaginary numbers or imaginary parts. So for our purposes right now, everything you're going to see is real. So it won't be as bad. You don't have to worry about that. So that will be an easy one for you to fill in.